1.
When should you graph? So solving a quadratic, you can graph. But graphing's a pain. When should you graph? When you're given a graph.
Not if you're, well, you know graphing isn't a pain.
If it's y equals or 0 equals, that's typically also a sign that you could graph. But really, the only time we're going to graph is when they give us a graph. They say, here's a graph, graph this quadratic. Because quadratics can be tricky and time-consuming to graph. After we learned how to graph, or we practiced graphing, then what did we have?
Factoring.
When did we learn to, or when should you factor?
0 equal.
It's got to equal 0.
Binomial, no C value. Yeah, it should be.
If it's a binomial where there's no C value, like 3x squared plus 9x equals 0. How would you factor that problem? What does it have? How could you factor 3x squared plus 9x? Alexis? There's a greatest common factor. You take out a 3x, you'd undistribute it, right? Greatest common factor. You should also factor if it's an easy trinomial. Like x squared plus 10x plus 25 equals 0. X squared plus 10x plus 25 equals 0. What are the factors of x squared plus 10x plus 25?
5.
X plus 5, x plus 5. Factors of 25 that have a sum of 10? Then we learned square roots.
Look for perfect squares.
We look for perfect squares. If there's perfect squares in that problem, we're probably good to go.
Vowels, that's the only requirement.
We also need an isolated x squared. So, I mean, if you have a problem, x squared equals 100, you could solve by square roots. What would the answer be?
X equals 10.
Nope.
X equals positive and negative 10.
X equals positive and negative 10. So we need to remember all square roots have 2 solutions
Except 0. And negative.
except 0.
And negative.
0 only has 1 solution. The other key to this is that there is no B value. You cannot square root if there is a B value. Remember, though, all square roots are going to have 2 solutions.
Except 0 and negative.
Except 0. 0 only has 1 solution.
But what about the negative?
We'll get there. And there are no negative square roots allowed.
Both will create an imaginary number.
No square roots of negatives allowed. If you square root a negative, what's your answer going to be?
Imaginary.
No. No solution.
No real solution is your answer.
No solution. After we did square roots, what did we learn?
Discriminate. Well, no. But perfect. Completing square.
Complete the square. What's your clue that this should be complete the square? Do you remember? What's the clue? What's the clue to complete the square? Okay, that's part of it. B divided by 2 squared. But there's something that tells us to complete the square. If the quadratic equals C. If the quadratic equals C, complete the square. Or could you make it equal C and then complete the square? Yeah. Luis was right. He said B divided by 2 squared is the new C value. Complete the square doesn't get a whole lot of love. If you'd like to make it your favorite, I'm sure it would appreciate it.
In fact, there will be 10. There will be 10 complete the square problems on YouTube, but I may need some help brainstorming.
And last but not least, what was the last one we learned?
The formula.
The quadratic formula, which includes the discriminant. Quadratic formula, when should you use it? It works all the time.
Any freaking time. The quadratic formula is guaranteed to work every freaking time.
Calm it down, just a scotch. It always works. What's the downfall of the quadratic formula? It's long. There are plenty of times that you could make a mistake, correct? There's a whole lot of substituting. I would say simplify the discriminant first. Because if you simplify the discriminant and you get a negative value, what's your answer? No solution. Alexis, put it away. Uh-huh. What is the quadratic formula?
X equals negative b plus or minus the square root of b squared minus 4ac over 2a. It's all over 2a.
X equals negative b plus or minus square root of b squared minus 4ac all over 2a.